The normal evacuation vacuum and recharge machines we use were great when the problem shop saw was a failed compressor, low refrigerant or leaking line, or bad clutch. But today's world, we're now dealing with variable displacement compressors, multiple electronic valve control for the clutch in our duty cycle of the compressor, computer-controlled systems. So we aren't adequate. The problem the shop sees is poor cooling, poor AC performance at a cruise or an idle. And then we've got multiple zones in the car with automatic temp control where the right and left side aren't the same or front and rear. A simple EVAC vacuum and recharge not only doesn't solve these problems, in many cases it will mask the real cause. And now we're doing double work. We're guessing at what to do with a car or forced into doing what we hope is a repair and having that customer drive it and return back. That's not an effective and efficient way to work with today's systems and more complex cars. And so Autel came together and has developed the AC909 system and components. So you can see what we have here, run by one of our tablets, is a complete system for working on HVAC. Not just a tablet to plug in with some manifold gauges attached to it, but an entire system with a concept of being modular so that we're not stuck with one piece down when we do it, and we're able to do more. Obviously, as we look here at our tablet, we can see we've got one of our tablets on top of a manifold gauge. That sounds pretty cool, and we're obviously thinking we've got a digital display of gauges along with scan. We'll take a look at all that, but also notice that I've got temp probes on my vents and on the AC lines. But where are all the wires? Everything is Bluetooth. You're unencumbered from your tablet to all the probes and readings throughout the car. In fact, you hang your manifold bar under the hood and it communicates Bluetooth with your tablet, where now I can sit in the driver's seat, work my AC controls, monitor both the system and what I'm seeing from the car together at the same time. Together. Now that's all pretty cool, but we've got a step further. It's not just a set of manifold gauges and a scanner. Autel's always been known for having an intuitive interface, for making a workflow that was the steps a mechanic would need to use. So an inexperienced or beginner technician has a workflow that's guiding him. The experienced tech has steps in the order he inspects them, and they also have the ability to manually move back and forth. And that's what we've done with our HVAC software. I enter into it, and as anything in today's legal world, you start with a disclaimer. Now we're working with beta prototype software, so it's set directly into our vehicle we're going to have for a subject. You'd have your normal selection screen at this point. I go ahead and click next. Reads our VIN. Our subject car, a 2023 Nissan Altima. Pretty common, normal type vehicle to have in today's world. I click OK, and I see the first new change in our world. A refrigerant configuration screen. Afterwards, I'll walk up a little closer. On here, it's telling me which type of refrigerant it's using. What's the recommended OE oil? But then it gives me some interesting stats about it. What type of compressor? Standard, variable displacement, electronically controlled as we see here on this car. And it talks about the evaporator and condenser configuration. Now, at first glance, we might think that's a little oversimplified. But in today's world, more and more vehicles are not a standard air-blown condenser and evap. There's liquid-cooled units. We have heat pumps on some of the more complex vehicles, and don't even start talking about EVs and hybrids, where that system resembles home air conditioning more than it does the mobile system we've looked at. Knowing how it's configured when we go into start is vital on knowing our steps to diagnose. Continuing on, it's going to let us know the capacity of that refrigerant and how much oil the system holds. So we start off by letting us know what that system is so that the technician can start his diagnostic steps in his mind. And this is available throughout the tool as I'm working on the car. I'll show you the quick link to get to it. I click OK, and it goes into my HVAC menu. Here on the left, it walks me through that order of steps I see. My first step I do is Graphical Diagnostics, a tip menu from our Ultra S2 we've had on other systems. We start off with reporting ability. I can name symptoms that the customer has given me of that car, and depending on those symptoms, I'll get follow-up menus about how often, how long ago it occurred, is it at a certain speed, is it at a certain temperature, so that I've got all that information on my report to relate to the customer how what I did in my repair solved the complaint they came in for. We're going to skip through those just for the sake of time. And now we have illustrated step-by-step instructions on connecting it up. Each one of these illustrations, by touching, I can make into a larger screen to see the illustration as well as the directions that I need. You'll notice in these first steps, it tells us to hook up a vacuum pump. We have an optional connection for that. We're just exploring what we're going to do with it. Here we're using one from our friends at Fieldpiece. This is a high-end vacuum pump because if you're doing top-level diagnostics, you should be working with top-level vacuum pumps and equipment to make it more efficient. I'll click the next button. The first step it's going to do is use that vacuum pump to clean and purge all my hoses in my manifold bar. This lets us use one set of hoses and manifold and simply change the couplers in order to deal with the two refrigerants. We don't have to have separate sets. All purged and cleaned. Now my final connections are starting the car, and here's where that graphical diagnosis comes in. I'm going to get rid of the left menu so it's a little bit bigger for you all to see. Now you can see we have a graphical representation of our AC system. We can see the direction of flow. We have color-coded the high and low side, as well as shading for the vapor and the liquid side of both of those systems. Information to know. You can see a lot of detailed information around. You come up to look, you'll notice by some, there's a little OBD2 plug. That's data we're reading from the car's computer and its sensors. Others show a little gauge, and that's your direct reading from your manifold bar or your temp sensors within the car. I'm able to compare what the car's computer thinks is happening to what I really know is happening to start my diagnosis. As we go around, you will see below and above the high and low gauges some abbreviations that some of you may be familiar with, but many technicians aren't, because we've gotten away from using what we should. Obviously, first up is the lower high pressure, and then we see an abbreviation of VSAT or LSAT. That is your vapor saturation point or liquid saturation point from your pressure temperature chart. I remember when we used to use that when we did AC, and we still should be today. That's the point at which the refrigerant changes state, vapor to liquid or back. By looking at that temperature from the chart based on our pressure, we know when the conversion's happening. Directly below are our liquid or suction line temp off of our temp probes. Those two numbers together give us a number called subcooling or superheat. What that's revealing is how much temperature the evaporator is pulling out of the cabin, or exactly how much the refrigerant is giving off in the condenser. These numbers are vital in diagnosing system performance. They can tell us about an overcharge. They can let us know when electronic controls and expansion valves aren't doing their job, when there's restriction. Now when we have that poor cooling performance, we can actually analyze what's happening in our system with real data that we need. As we go around, you'll see there's touch points by each of the components. When I touch it, it lets me know what data is available, any codes that are there, and these will be linked to a special AC-only database from our friends at Motor, so that now I can find OE information on test procedures and specs. We give location graphics like we did with modules in the S2 to let us know where the component is that we're working on. Wi-Fi's a little slow here, so bear with us. And we'll move on while that's loading. It also lets us know what active tests may be involved as well. So as you can see, by going around with those touch points, with that extra information, I'm able to perform an in-depth diagnostics of the AC system and refrigerant under the hood. And we talked about multi-zone. I can also look at the ventilation system inside the car for knowing where they are, comparing my vent temperatures with our wireless probes, as well as the blower motor speed, the airflow, all of my flaps and blend doors. With two simple screens, I can diagnose a system. And if that screen's too busy for you, I'm able to select which data items I want to display. If you want to take it down to just high and low pressure, you're more than welcome, but why would you revert back to what we just said was inadequate when we're giving you the need to go beyond? Once I've done my diagnostic screen, now I may go back and start that workflow process, checking components. The first one it's going to have us check is visual inspection. Now this isn't inspecting the system. This is going to pull some of the refrigerant out of the vehicle into this large backlit sight glass where I'm able to actually see what that refrigerant looks like and then compare what I'm seeing to known good and bad. Is it clear? Does it have some dye? Is it red, green, or yellow dye? That helps in what I'm going to look for leaks. Is it too much dye? Or are there particulates, metal fragments, oil, and other things in there as well? Yeah. Oh, so you're able to apply what we use for other fluids in the car, transmission, oil, power steering, to what we're doing with AC. And naturally, all of that's going to show on the report so you can explain to the customer why you're performing the repair. Once I've looked at it visually, we actually go another thing of reminding you of doing a check of the evaporator. Has it got pet hair, leaves, moisture inside of it causing it up? And the condenser. The airflow for both of these is going to affect your AC performance. So we performed a visual inspection of everything in the system. We know the condition of the refrigerant. We know if the main components, EVAP and condenser, are flowing right. Now we're going to check the compressor. Get a little bit of a warning screen, and we see we have two ways to hook up. I can connect my tool direct to OBD2 and perform and look at data from the car's computer and the tests that are there. But I also have the option of connecting directly to the compressor. Now I can control that as well, independent from the car, and see what the car's doing. I'm going to choose that option. Lets me know what my tests are going to be. Gives me an illustration of my compressor location and type, looking at that plug. And then I'm able to actually hook it in a T. We have dedicated connectors for the different types of compressors and systems. A shout out to our friends at R&Y Compressor helping us get all the different connectors available so that we know what to do. So now I'm teed in. The car's computer can still do its job, but I'm also able to take over with my tool and my compressor control box connection to control that compressor independently. I'm going to move forward in my test, obviously make my connections. It's going to check resistances and voltage that you would normally use another tool for, right direct through the control box of the tool, giving me data initially on that clutch and its resistance. From there, I follow the illustrated steps again, bringing the car up to speed, all the AC turned on full. And now I instantly see a graph showing me my high and low pressures, obviously low coming down, high going up, and the duty cycle, how that electronic control valve is making the compressor work from full on as it starts to go and slowly lowering. Now, if you're old school and like gauges, I got your analog gauges. But why would you look at that? I'm seeing a microsecond, maybe the movement. But much more valuable is the trend in a graphic. So by having this line graph, I can now see trends and know what's happening and refer back to what happened before. As the system comes up to pressures here, low dropping into range and high, the compressor duty cycle going down, at a moment here, it's going to stabilize. When it does, the tool's going to actually highlight to let me know I've reached that stabilization. Now I can see the compressor's working, my pressures are in range. Let's jump to our next screen. By the way, that screen is pinch zoomable, just like anything with our tools. I can zoom in. Low pressure still coming down. Also have my temperatures up here as well. And it lets me know it reaches the stabilization point and highlighted it. Now I know the car came up to speed and work. I'm going to go to my next step. Return the car to idle. And now a similar graph, but what's happening here is I've taken over with the box. I have the compressor at 20% duty cycle. High pressure coming up, low pressure going down, and when those pressures stabilize at what 20% should be, it will highlight them again. Highlights them and lets them run a couple of seconds, and then we're going to see as it goes through, it's going to step, there we stabilize, it's going to step that compressor to a 30% duty cycle. Wait for the pressures to change again, and then when they stabilize, go to 40. It will keep stepping the compressor up, allowing me to see that that compressor, independent of the computer and the rest of the system, is actually functioning and bringing my pressures up where they were. I'm checking the actual values of work. We'll exit that test. And go to our next step in the workflow. If I've suspected I had low refrigerant all the way through, I can of course do my next steps in the recover. But if I'm unsure, we have a refrigerant level test. Again, we're going to hook up our hoses, as its illustrations say, clear our manifold gauge and hose set so we're ready to move on, connect up to our car. We're going to start a timer to run that vehicle up to operating temperature, both under the hood and the refrigerant system. If you remember your ASE test, your mobile air conditioning 609 test, this is one of the vital steps in AC diagnostics that we often forget. My tool reminds us and provides the timer, and I can bypass it, but it's warning me, you know you're doing this wrong. Now we see our pressures as the vehicle runs, and pretty obvious on this demo subject, it's low on refrigerant. So we know our vehicle's low on refrigerant. We can see it's not where it needs to be. We're going to go to our next step. Refrigerant's insufficient. Now it's going to actually go into recovering that refrigerant. Add on an optional recovery compressor unit. We've got our tank on our scale, which is also Bluetooth. You're not cumbered by wires anywhere. We go to continue. Warning screens. Put your tank on. Do your tare weight. Where are we at now? Make our connections. Our vacuum pump to clear our hoses. Again, making sure if we've taken time in between two steps that we do a run of the vehicle to get up to speed, up to temperatures. Get our recovery hooked up through to our tank. And now we begin to pull refrigerant from the system. We can see the pressures. We can see how much has been recovered. It will tell us at the end finally, so that we know. The scale knows when it's getting to zero with opening and closing valving to the recovery tank. We're watching everything come down and through. It lets us know to recover out of both and when to open the high side to complete recovery correctly. It'll walk me through those steps. When we're done or it reaches complete, it will show me what was recovered so I can know how low that system was. Obviously, with what we saw in gauge reading, it's incomplete or has air or other things in it. We'll go ahead and back out of here to go to our next steps for time. So now I've got a system that's empty. I'm going to do my necessary repairs that I may have noticed while I'm going through. At some point doing that, I'm going to move to the next step, and we got unique again. Notice the nitrogen tank. We supply a regulator for you. You will have to obviously get a nitrogen tank from your local welding supply. Simple, pure nitrogen. It's inexpensive. It's easy to work with. It's not a specialty gas you got to go buy somewhere different. I'm going to go into those nitrogen test menus, and I have two steps. First is a nitrogen purge. I go through and purge the vehicle. It gives me my hookups. I connect, cleaning out my hoses. And now I'm putting 29 PSI into that system. And when I do, I'm going to go through filling it to the pressure, and then opening the valve to purge that pressure off and purge nitrogen through. Why am I doing a nitrogen purge? Nitrogen is a natural drying agent. It cleans my system. It removes excess moisture. By doing this, my vacuum step will be faster, more effective, more efficient, and with less moisture coming out of that system, I'm not contaminating my vacuum pump oil as much. So the life of both the oil and the pump are going to be longer. So it's making the rest of my equipment more efficient by doing it. Once I've completed a purge, then I have a second test available, a nitrogen pressure test. We've all done the vacuum leak checks and experienced the O-ring being sucked in and sealed, and then we apply pressure to find that leak. Now we're running into cases on small leaks where we're using dye and having it come back, or we're potentially sniffing or trying to run it for time. We're wasting refrigerant and time doing work twice. Here, I'm going to turn around and fill that system with 150 psi of nitrogen. But notice I am also monitoring my temperature. Once I get it filled up, start a quick timer for stabilization. Now my system's stabilized with nitrogen in on both sides under 150 psi. I've got options for this test. If I'm simply going to do it on observation alone, I can go all the way to a 12-hour leak count to check for the smallest leak. I can shrink that up to just minutes or 1 hour, and it's accelerated. We won't have to wait. Filling it with pressure. I'm also monitoring temperature. Why? We all know that gas pressure changes as temperature does. So I got to read my temp, know the change in my temperature throughout the test, and the change in my pressure. But the tool is also using what they call rise over run. It's looking at how fast is that change happening. Based on that, within the time, it knows that your rise over run's too high, and I don't have to do the whole hour. It's going to warn me there's a leak in this system. It's testing things much more effective and efficient. We'll go ahead and get out the nitrogen test. Our next step at this point, if we made any repairs or that necessary, is to go into a vacuum. We all know, right? We vacuum that system. The leak check was something else I talked about. We're vacuuming to remove moisture. That happens by boiling the moisture off, and if anybody wants, I can get into explaining the principle of what it does. We'll go through and do it, wearing our gauges naturally. But notice how we measure vacuum. We're measuring in microns, not inches of vacuum. A 0 to 30-inch scale is nowhere near as precise or complete as 300,000 microns down to 300. And by watching that scale, we're able to see if moisture is being boiled off. Those microns will rise up and fall as each pocket is found, or refrigerant pockets. We're sucking through the low side. On the high side, we're installing a separate vacuum gauge, so that we're actually testing if the vacuum's going all the way through both sides of the system and measuring complete. High-end vacuum pumps have a ballast. When they're first sucking, it lets the moisture blow out without hitting our oil. Then to get a deep vacuum at 3,000 microns, it'll tell us to close the ballast on our pump if it's equipped. This helps our pump again keep the life of its oil and the pump together. So we're making the equipment more efficient, the technician more efficient. It'll go through a vacuum and then lead us into doing the whole test. Even though we've done a nitrogen purge, we may not need to. Once we've accomplished our vacuum, now we're at the point of charging our system. Going to our charge menu. Again, through our hookup connections, using our scale, vacuuming out our hoses as needed, establishing our tear weight, making our connections. Now the machine's monitoring. It knew, remember our spec chart? It's right there anytime you want it with that blue hyperlink. It knows the fill of this car, so it's looking for that amount of refrigerant transfer. The Bluetooth scale will shut off the in and out for us when we're at our point. If its slow charges are incomplete, it'll let us know. Close the high side, go ahead and start the car and pull it in through the low side to complete our charge. The tool walks you through those steps. So that's a step-by-step, but hey, some of us are experts. Some of us know all this stuff, but we want to get to work where we want to go. So I can go directly to a gauges menu and observe my gauges. I can go straight to that graphical diagnostics menu and use that trail around to be able to diagnose the system and look at those conditions. I can drop down to do my nitrogen testing for gauges and do vacuum checking. So we've given an expert mode for those guys that want to walk through. Finally, your ability to diagnose and test is only as good as your equipment, right? So first thing I need to know is that vacuum pump working? We are constantly misled by older vacuum pumps that aren't performing or drawing, or maybe have oil that we didn't pay attention to and it's not in a good enough condition. So I can hit that vacuum pump check under maintenance, connect my independent micron gauge to the vacuum pump directly, and see how fast that pump pulls down, and if it's able to pull down below 300 microns. Is my vacuum pump working? If it's not, that's going to make my diagnostics and my repair inappropriate. We also need to know if our hoses, gauges, and connections are good, right? So I go to a manifold gauge set test, where I can use the vacuum pump to pull down the entire gauge set manifold bar and know if my hoses, connections, or bar itself have any leaks. So I know I'm working with proper equipment all the time. Our final test menu allows us to take our temp probes, put them on a no-good source, and compare the actual temp to what they're reading to verify they're good or calibrate them. You can see Autel's endeavored to create a new solution to AC, something more effective and more efficient than the recovery machines we're using today. They're adequate on that gross failure I talked about in the beginning of yesteryear, but they don't fix the cars you're seeing today, and certainly can't do the cars coming in the future. So we've given you systems and the components and testing that we've taken from the world of HVAC and commercial AC that is now merging with what we're seeing on today's cars, an advanced system. It'll be on display throughout the show, so you can come up, touch it, work with it to get a feel, put it with us more, and of course we're here for questions. Again, in the prototype stages, but we're hoping to have this developed and available to you possibly by this year's AC season, somewhere in the early spring, so that you can start fixing the trouble cars and getting your customers the help they need today. Thanks everybody for attending. We appreciate your time here and enjoy the show.
Thank you. Thank you.